In this video, we're covering anti-derivatives. So since anti-differentiation is the reverse of differentiation, we can find an equation for the antiderivative function, which is on your screen. So if we have dy over dx equals x to the power of n, then we can find the original function y equals 1 over n plus 1, x to the power of n plus 1 plus c. There always will be a c there because we're unsure of what this constant could be. There could have been any form of number without an x that could be at the end, therefore we use c to show that. Now, essentially what is happening is that the power of your differentiated equation or function goes up by 1, and out the front you get a 1 over the new power. Now, we do have some main antiderivative rules which can be seen here. So these are the main ones we use regularly. So if we have dy over dx equals k, then our original function will be y equals kx. Now, if we have dy over dx equals kxn, then we know that y equals 1 over n plus 1 kx to the power of n plus 1 plus c. So you'll see how this comes into it in a little bit. So don't worry if you don't understand how these are working right now. So here we have a function, x to the power of 5 minus 4x cubed. Now, remember the power goes up by 1, so our x to the power of 5 now becomes x to the power of 6. But before we begin, I will say that this is our function that we're going to. So we will have x to the power of 6. But you'll notice that in our differentiated function, there wasn't a 6 out the front. So we need to have our 1 over 6 here, because that'll essentially cancel out if we differentiated that. Now the next thing we need to focus on is the 4x cubed. Now the 4 remains, so I can write that down. So we're going to focus on our x cubed now. Now that changes to x to the power of 4. And then we know that we need a 1 over 4 at the front. So there's little times in there. Alright, so let me rewrite that just to make a little bit more sense. So we have a 4. We have our x to the power of 4, our new power, because the 3 here went up by 1. So now we have 4. And we add our 1 over 4 at the front. Okay. Now we need to simplify this and just tidy it up. Our 1 over 6 x to the power of 6 does not change. It remains there. But our 4 times 1 over 4, so this section here. Now 4 times 1 over 4 is just 1. So we can either put the 1 there or just ignore it. And we have x to the power of 4 that goes there. So we'll look at another one here, a more longer one. So we have fx here, and I want to get to our original function. So there are some ways you will see this represented as fx like this, and you can say that we're going to go to fx. And sometimes you'll notice that we go from fx to a capital F. It's just different ways of showing the same thing. So again, we have x to the power of 4 out the front. That becomes x to the power of 5. So we need a 1 over 5 out the front. We then have a 4, so the 4 stays. And we're going to times it by our x to the power of 4. So 1 over 4 goes here. We have a 9, so 9 times stays. We have x squared, so that becomes x cubed because it goes up by 1. And then 1 over 3 goes there. We then have a minus 6x, so the 6 stays. And we get x to the power of 2 now, so we get a 1 over 2 here. Alright, I'll zoom out a little bit. That 5 now just gets an x on the end, like this. Now, remember, we do need to add the c, which I didn't do on the original one, but we do need to add a c there, because we don't know what it is. Now we need to tidy things up. Our first term does not change, so 1 over 5 x to the power of 5. Like our previous one, the 4 times 1 over 4 becomes 1, so this remains as x to the power of 4. We get 9 times 1 over 3, which becomes 3, and then the x to the power of 3. We have 6 times 1 over 2, so we get 3x squared. We have our 5x that doesn't change, and then we have our c. Alright, so you start to see a pattern here. When you go finding the antiderivative, the power goes up by 1, and you get that power as a fraction of 1 over that power out the front. Alright, if there was a constant, such as our 4 here, 9 and our 6 are a coefficient, they stay, and you still multiply them by our fraction that we find. So there is a chain rule for this. So here on your screen, dy over dx equals ax plus b all to the power of n, and we do have a formula there that we can use to find the antiderivative. So here we have an example. So the first thing I'm going to do is actually write it out. So we have dy dx equals 3x plus 7 to the power of 8. We have a formula there. We have a, n, and ax. So I'm going to write that out, that our y equals 1 over a, n plus 1, ax plus b, n plus 1, plus c, okay? So we know our a will be our 3, so over here on the side I'm going to write these out. A equals 3, b equals 7, n equals 8, alright? So all I'm using is the formula from up here to find out what a, b, and n is, and I'm going to write it for the side. So now that I've got that, I can just substitute these in. So I'm going to have 1 over a, which we said was 3. 8 plus 1 goes here. We then have 3x plus 7 to the power of 8 plus 1. And then we have our constant. So now we can do some tidy ups. We have 3 times 8 plus 1. 8 plus 1 is 9. So 3 times 9 is 1 over 27. And then we focus on our bracketed area. So 3x plus 7 becomes 8 plus 1, which is 9. Plus c. So you could leave it like this, or alternatively, you could write it as 3x plus 7 over 9 to the power of 9 over 27 plus c. Right? Either way of these I'm happy with, and I think both of them will get you your marks. So we'll look at the general chain rule now. So here we have if dy over dx equals the differentiated function, so fx there, or the original function to the power of n, and we get the formula there. So to begin with, we should highlight and mark some of our things. So using this, we're going to identify what our differentiated function is, the original function, and what n is. So we know that fx will be our front term, so 8x to the power of 3. I know that fx will be the bracketed area, so our 2x4 minus 1, and we know that n equals 5. So knowing this, we write our formula. While it is at the top, I always suggest you rewrite them. So fx, n plus 1 plus c, and now we can do some substitutions. So we get 1 over n plus 1, which is 5 plus 1. We get our original function, which is our 2x to the power of 4 minus 1 to the power of n plus 1, so 5 plus 1 plus c. So now we can simplify that down a little bit. So we get 1 over 6, 2x to the power of 4 minus 1 to the power of 6 plus c. And again, you can leave it like that, or you could alternatively show it as what you see on your screen now. To recap the video, on your screen you can see all the formulas we use to find the antiderivatives, but remember, essentially for the basics, what you're doing is the power of your differentiated equation goes up by 1 for each term, and when you do that, the fraction that comes out the front is 1 over that new power. So again, if I had 3x to the power of 2, this is going to go up. So if this is dy dx, the 3 remains, and we're multiplying it by the new fraction we're going to find. Our x power goes up by 1, so to 3, and then we have 1 over 3 out the front like that. And this simplifies down. They essentially cancel out to x to the power of 3. Alright, so remember, that fraction that comes out the front is 1 over the new power. But you always got to multiply it by the same coefficient that remained there in the differentiated equation. Now, it's a good idea to write these down somewhere so you can refer back to them when you're answering types of questions such as these.